Good morning. It's Saturday where I am. It's time for some feedback regulation. And see, here we have feeding going on here. And so there are hormones that say, okay, you've had enough. That hormone's name is leptin. But you know what keeps that hormone from working too well? Sugar. So cut down on the sugar. So here we go. Okay. So explain how positive feedback affects homeostasis. Homeostasis would be like something, whatever's on the y-axis, staying relatively the same, right? Positive feedback is not a homeostatic kind of mechanism. Positive feedback wants some kind of thing to keep going and going and going and going, right? In this case, fruit ripening, we've talked about this one. We've talked about all these actually, right? So fruit ripening is triggered by a gas hormone molecule produced by the plant, right? And here we're also once again in the realm of this is a signal molecule and it's going to hit a receptor. It's going to cause a signal transduction pathway. That's going to cause the response that is called fruit ripening in this case, right? So what this is about is that ethylene causes fruit ripening, marked in percents here. Fruit ripening triggers more ethylene. More fruit ripening, more ethylene, more fruit ripening, more ethylene. Something else they could ask you in this kind of thing, I can't get that to work. In this kind of thing is, with this graph, right, is the difference in ethylene production at this point in time and this point in time significantly different? And yes, it is, because their error bars don't overlap. Okay. So here's two other examples. We did the fruit ripening, right? Here's the onset of labor and childbirth. I think we mentioned this before. We didn't quite get to reproduction in class. So here you have a couple signal molecules. These are working at long distance. They're going from this body part to that body part to that body part. That's another aspect of this, right? This is the one we're focused on here. Oxytocin causes muscle contractions in the uterus. Muscle contractions in the uterus, we're going to skip that part. Muscle contractions in the uterus cause more oxytocin to be released, which causes more muscle contractions, more. We get that same kind of graph until little baby comes out or that ripe fruit falls off the tree, and then the signal is no longer given, and so now the oxytocin level and the contractions both start to go down. Notice that the oxytocin could have been on this y-axis, the contractions could have been on this y-axis. It would have been the same story, more with positive feedback. Okay, so here we have the last of these three, right? Lactation in mammals, the physical stimulation of suckling, a little racy photograph here, is transmitted to the hypothalamus brain part, right? This sensation of touch, that triggers it to release a chemical here. Once again, we're going long distances to target cells. This chemical hits a receptor in these cells, causes it to release another chemical. Ooh, look at that, oxytocin, same one, right? Same signal molecule, probably the same receptor, but in different cells with different signal transduction pathways, different end result. This is get rid of milk. Okay, and sorry, back to the positive feedback, more and more, right? More milk production causes more suckling, which triggers more milk production, until the suckling stops, then the milk production will go down. So this is what the graph for positive feedback looks like, as opposed to the negative feedback graph. There's not much space on this page, but the negative feedback graph, like we said, whatever you're monitoring, it's going to stay roughly the same, because when it goes up a little bit, the feedback of that going up, in this case calcium levels, right, is going to be sensed by some kind of cells that are going to set into motion something that will cause it to go down. In this case, it's the release of yet another hormone going to yet another long distance target, right? And in this case, triggering signal transduction pathway that causes calcium levels to fall, probably because of opening calcium gates in cells to let that blood calcium get into cells, right? So this is the idea of returning a system back to its target set point. That would be like right here. This is where we want to keep blood calcium levels. This is where we want to keep blood pressure. This is where we want to keep most things are regulated by negative feedback mechanisms. The positive feedback things are much more rare examples of. Okay, so here thyroid hormones were one of the in the list of signals released by one cell type. Here's some thyroid hormones. There's some other thyroid hormones that we're going to come back to in a little bit though, but here is another classic example. This made its own little separate bullet, but remember, blue shading, know it for sure, not blue shading. These are just examples that we might use or that your teacher can use. And so here's the blood sugar one, okay? This is the same kind of story. What happens when blood sugar gets too high? Cells are stimulated to do something that will cause it to go lower. Negative feedback. The response is opposite of the stimulus which started the things in motion, right? What are these things? Well, pancreas cells say, ooh, there's lots of sugar in here. Let's make and release insulin. Here we have the story of making proteins, right? Wrapping them up, Golgi, releasing them, exocytosis. All these stories are related, right? What does insulin do? Insulin hits all kinds of body cells, hits a receptor. It causes them to take up more glucose. Signal transduction pathway is in the middle of that reception of the stimulus and the response. Okay, so if they take glucose out of the blood, that means it drops. What happens if it goes too low? Well, here again we have an antagonistic hormone. I forget if I said that word before with the calcium ones, but one hormone makes this happen. Another hormone makes that happen, the opposite. They're called antagonistics. This is often part of a system of homeostasis, again, keeping blood sugar levels hopefully kind of steady. So here's thyroid hormones again. Here's the negative feedback kind of idea again, right? So here we have a different kind of thing though. Notice before what we talked about was some kind of dynamic like calcium level or sugar level, and those levels were kept steady, and it's those levels which triggered all these signal molecules. But here we have this aspect also. This is almost always the case. This story starts in the hypothalamus, sends a molecule to the anterior pituitary. This is long distance travel, even though they're pretty close together, right? Sends another molecule, all these are signal molecules, receptor, signal transduction pathway, to the thyroid, which produces these. What do these do? These say to cells, do some more Krebs cycles and things, release some more heat. What was the original message from the that the hypothalamus kind of read? It was body temperature. But what's the hypothalamus also reading? It's reading the level of this chemical, which it was indirectly responsible for making. So besides measuring body heat, right, it's also measuring the level of one of these chemicals. So on a graph, it would be the same kind of negative feedback idea. Either body heat would stay around the same, or the level of this chemical, or that chemical, or that chemical, all homeostasis. Homeo means same, stasis means same, right? It's kind of redundant to say both of them. So here's a comparison now. I'm bringing this one back because it is the same negative feedback concept, right? But this time it's in a chemical pathway as opposed to one that involves body parts. So this is all happening inside of one cell where something, end product, as it increases in its number, right, it itself is the feedback to shut this mechanism off that makes me keeping the level of that, this is an amino acid, kind of level in a cell, right? But it's the same kind of thing, right, when body parts are involved, sending messengers to each other, which is negative feedback regulated to keep something like body temperature or whatever at a certain level.